Okay. Good morning. It is Thursday, June 18th, 2026, and we have had a very eventful 24 hours. Nathan, good morning.
Good morning, Prakash. How are you?
I am very good. And what has struck your attention?
Well, I think the whole AI world, from what I saw on the timeline last night, was just blowing up over Midjourney Medical's new revelation and the beautiful launch video that they used to show off some of their plans. I imagine everybody who's tuning in has seen this already, so I won't, try to belabor it too much. But in short, they are planning to do an ultrasound body scan that they're planning to productize in kind of a wellness sort of vibe, where you will be for just a minute, like literally 1 minute, they say, you'll be dunked into a tank of water, and the water is needed because the ultrasound doesn't pass through, it doesn't propagate well through air. So you get dropped down into this pool of water. There's a ultrasound all around you that emits ultrasound in kind of a rotating fashion, bounces off of you in the full 360 degrees, and is captured and is interpreted. And maybe one of the most striking things about what they showed is just really beautiful visualizations, which obviously is right in Midjourney's wheelhouse. I thought this was, above all, a really great example of an AI company putting forward a truly different but fundamentally positive vision for the future. So often say the scarcest resource is a positive vision for the future. And this is one positive vision for the future that it seems like everybody could get behind. And so I absolutely applaud them for that. The idea that you could get a 1 minute scan, and that, there could be radical abundance in seeing inside our own bodies, and even make it beautiful in a way that I think has actually maybe more medical consequences than immediately meets the eye. We can get into that maybe a little bit more too. I thought it was awesome, beautiful, and inspiring, and just exactly the sort of thing that we need more of. I would love to see more of this kind of stuff come from other people who have suddenly got very wealthy in the AI boom.
What struck me was I had a lot of thoughts on it. Number one, I love David Holtz. He's definitely been one of my favorite people in AI for a very long time. It struck me that he had used the wealth that he'd obtained from Midjourney in such a, as you pointed out, a positive way. And it also struck me that this is only the beginning, because one of my theses is that there's going to be a capital explosion as all of the money that's being made in SpaceX and Anthropic and OpenAI is going to go into the hands of these fairly young, very empowered, very technologically sophisticated, entrepreneurial people, and they're going to be able to deploy this capital in ways that the normal pension fund trustee would not like or would not be able to support. And to a large extent, risk taking in the United States and globally is driven by pension funds and insurance or organizations, which are both regulated by the state. And a lot of bets are not made for this reason. So this is one of the things that I'm very excited about, that as the wealth devolves into these hands, which are able to make these large bets, we're going to see more of them getting made. So that's one obvious thing. The second thing that struck me was he decided to go into medical. Medical is 18% of the US economy is medical, and it's always a growing percentage, because whatever wealth that we have, we end up using to improve our health at the end of the day. What struck me is that it's always been a very hard area to innovate in, because of regulation and because of privacy issues and because of all these issues. So he decided to tackle the hard problem. Kudos to him. And as you have pointed out before, the medical establishment is not very on board with this. One of the things that happened during COVID, for example, at the early stages of COVID in Seattle, the labs that were testing for flu there back tested for COVID, and they found examples of COVID even before the official COVID announcements. They wanted to alert the people who were positives, but were banned from doing so by the FDA because the FDA doesn't like it when you don't get consent from patients before you test for something. And they don't like it when you disclose to patients something that you haven't kind of ethically discussed and decided that this is okay for disclosure. So the FDA actually banned these labs in Seattle from disclosing to the patients. And this is one of the things that has always struck me about the US regulatory system in particular is that the FDA is kind of very watchful because they don't want people to get information about themselves and misinterpret that information and say like, oh, you're at 95% risk of breast cancer. I'm going to cut off, I'm going to do a mastectomy, right? Like they don't want people to have that kind of information, and they don't believe the public is ready to directly receive very technical pieces of information. And this is actually not very well known in the public. Everyone thinks kind of like you have your right to the information. No, the FDA is not going to allow you right to the information from your own body. They don't believe in that. So he started off by saying that they were only going to do body composition, and body composition is really measurement of body fat, which is a big deal because when you take GLP-1s now, you lose both fat and muscle. And so if you have this kind of body fat composition monitor, you can figure out how much muscle you're actually losing and whether it's actually detrimental to you to actually continue to lose weight. So this is a pretty important thing. But it's also something that the FDA doesn't regulate that well because right now, in order to do it, you need to go into a bone density measurement machine, and that's almost a little bit like an X-ray. It shoots rays into your body. This is going to be able to do that without going that far. And so I think for people who are conscious of their health and want to know what their body fat is, this is going to be something that they're going to use.
Yeah, I mean, if the government thinks that they're going to block people from using this technology, I think they're going to have a real fight on their hands. And this is going to probably play out in so many ways. I mean, I've talked about this probably ad nauseum at this point, but in the whole cancer experience that I recently went through, fortunately, I didn't have to get off of the standard. My son didn't have to get off of the standard treatment protocol. Like it worked for him, and all the exotic stuff that we were scouting out, we never really had to actually try to get our hands on. But I was already gearing up for a battle on so many fronts. Just even the DNA testing that we did, which is not standard, and which fortunately we didn't have any real trouble getting our oncologist to support. That like fundamentally changed my information landscape and how I was thinking about how confident I could be that he was in fact cured. I think we're like over 99% now, given all these results. We wouldn't have been able to get to that level of confidence otherwise. And in terms of talking about the hypotheticals, like, well, what if this next test were to come back a little bit positive? The answer is just like, well, we wouldn't treat on that anyway. We would really need to wait for gross disease. And I just think, boy, people are not going to be content with that for much longer. That when we have these technologies, and especially this one, I think is what makes it so promising. And obviously they have to deliver, right? I think a little dose of kind of skepticism is probably warranted. Will this ever actually happen? I don't mean to cast doubt on that, but it's not insane to wonder. But assuming that they can actually deliver on their promise, the fact that it takes a minute and therefore is probably going to be pretty cheap, and I don't know what their retail price will end up settling at, but presumably it is something that they can operate quite cheaply on the margin. And the fact that it's so beautiful to look at. People will be able to study this for themselves, I think, in a really effective way. And of course, there will be, all the AI study of it as well that I think the medical establishment is not really taking into account. The responses have been, well, the ultrasound doesn't see this that well, doesn't see that well, or we don't actually recommend whole body scans because there's a lot of false positives and all this kind of stuff. And all of this is just feels to me like kind of fighting the last war, is sort of a scarcity mindset on multiple levels. People will, if there's anything like the good future, people should have time and motivation to put into thinking about their own health. Looking at one's own body in this way, I think is just going to honestly be captivating for a lot of people, right? I mean, how much time goes into how we look already. And now this is a way to look inside and potentially find stuff that is of interest. Sure, will people like have scares and, see something that turns out to be nothing? Like, I'm sure that'll happen all the time. But I think it really underestimates people, and it also really underestimates the technology and how refined it's likely to get, especially if they really are able to scale it out and create this sort of scan abundance that they describe in the vision. These sort of false positive issues, I think, will fade away pretty quickly. We'll get good at reading these scans, both because there's nobody more motivated to really study it than the patient themselves. And when it's made beautiful this way and accessible, I think that the latent potential for somebody to read their own scan and triangulate what they're seeing with other data that they have, just how they're feeling. I think that will be very powerful. But the refinement that the AI layers will put on top of this as well is just, you just don't hear an understanding of how fast and how much that's likely to progress once you have big data of this sort in the reactions that you see from the sort of, um, let's say, cautious establishment that have popped up so far.
One of the things that struck me about the Midjourney announcement is that this is, I think, what I would call really like an AI native idea, in the sense that when he decided to do something, he decided to look forward 3 or 4 or 5 years and look at things which were not yet available and would not be available in that time frame if he didn't do them. And he focused on creating new data. And this is something that we've seen, I think, in periodic labs in a couple of other firms, where the defensibility of the idea comes from the fact that they have data that no one else has, and they're the ones that are creating it. This is quite different from, I think, labs which are kind of operating on other people's data, which is what the early foundation models and the language models really did. They were operating on kind of Reddit data and other people's data. And so the defensibility of the idea comes really from, having your own data at this point. And David Holtz is one of the pioneers of this, because when they set up Midjourney, the one thing that they did, which was quite different and which they stumbled upon really early, was this idea of doing fast generation first and then forcing the user to pick which ones to upscale. And so they basically forced this kind of A/B testing on the quality of the images early on. And this, I think, helped them really kind of get a much higher quality than they would have been able. Had a very eventful.
There was a little weirdness on the sound there. Do
Yeah.
you hear me?
Yes, I hear you.
Yeah. Okay. I'm not sure what happened, but yeah, I mean, these data bootstraps are just, it's the first step toward a, much brighter future, really. I think back to how, and this is a stylized history. I'm sure that people could add important chapters to it, but the image understanding and the image text unity that we have now really started with some pretty rough stuff. The original clip was taking a huge number of photos, pairing them with their captions, and just trying to get an ML system to align its understanding of images with the understanding of captions. The problem initially, of course, was that those captions were generally very bad in terms of, did they even actually describe what was in the photo? There was probably, if you just think of photos on the internet and the way people caption them, some of them are very literally captioned if they're product photos or what have you. Many of them are all kinds of other things that are captioned in all kinds of other ways with jokes or memories or, notes to one another, whatever, right? All this stuff is kind of so common that the data was just extremely, extremely noisy. And yet they were able to get enough of a signal out of that it became one notable path to image generation. And with each generation of model that followed, a huge part of what they were doing is refining the data and more closely aligning using the new ability to caption images, to clean up the data, to refine the process, to get image and text more and more closely aligned until finally we're at this point now where we have this deep fusion. That process just is happening over and over again in all these different places, right? It's um, Jim Fadden, we talked about yesterday with his open source kit to kind of do RSI on a small fleet of robots that many small labs could afford. But he's previously articulated a very similar path for robotics, where all kinds of video data can be initially kind of a noisy source, but as they refine, there's probably going to be all these models that will kind of translate random videos that you might have into first person POV videos, which then can be used to train. So there's going to be all these little tricks played out over and over again in all these different modalities. And this, I think, will mean that the ultimate quality of these scans and our ability to interpret them, we should expect is going to be far, far beyond what you get when you go sit down at a ultrasound, and have a technician look at it today, which is already not bad. But this will be so much better, that I think it's like you could sort of see who has kind of figured out that this pattern is going to repeat across all these different modalities, and
Yep.
who hasn't, based on whether or not they're kind of taking that into account in their reactions.
Yeah, indeed. Maybe in terms of looking at reactions in AI, let me just segue to one of the big pieces of news yesterday, which is Noam Shazir. Noam Shazir is one of the authors of the original Transformer paper. He's one of the leading lights in AI. He's been one of the leading lights in AI for a couple of decades now. And yesterday, he made this bombshell announcement that he's leaving Google. And he said, "I'm excited to share that I'll be joining OpenAI and look forward to working with the exceptional team there." This is after he'd been at Google for about 2 years, after they purchased Character AI for $2.6 billion just to get their hands on him. And here he is about 18, 24 months later, he's leaving Google again. Nathan, what are your reactions to this one?
Well, this explains why I couldn't get him on the podcast, working through the Google comms team, for one thing. Yeah, it's big news for sure. And I don't know how big a news it is at the same time. Macro, some very significant percentage of all the people working at frontier companies right now have some history at Google DeepMind over the years, right? So it's, in a way, like this all came from Google, and the whole space is sort of a Google diaspora. And yet, they continue to be very serious players with, I would say, probably still the deepest talent pool and the broadest set of research bets. So having lost all those people and still maintaining that position, there's I think a good reason to think they will survive this too. They've also got 25% of global compute. So that's a huge strength that is not moving. We've seen something similar with OpenAI, right? They've lost a ton of people over time as well. Many executives, at the leadership level, basically the whole leadership team at the time of the Sam Altman firing has turned over since then. So many examples of key people leaving and the companies chugging right along. And yet it does feel like, okay, there might be something a little bit different going on here. Or maybe even if all that's true, and obviously the company is a lot bigger than one person, what does it signal? What does it mean? It's hard to feel like it doesn't mean anything. Certainly, it's a vote of more confidence in his ability to do what he wants to do, and he definitely seems to be one who's expecting pretty radical change on a not crazy long timeline. Seems like he does feel like, at a minimum, we can say he feels like he's going to be more able to impact that timeline at OpenAI than he would be at Google. Clearly, it can't be an economic move, right? That's one thing I think is definitely important to keep in mind. Like, he's been very well compensated by Google, so I can't imagine this is for a few more dollars. It's got to be for reasons of mission and his sense of his likely impact.
So let me just share a clip from a podcast.
For models you care about.
In flops, the global total global inference
It's
in 2030.
I think just more is always going to be better. Like if you just kind of think about, okay, like what fraction of world GDP will be, will people decide to spend on AI at that point? And then, like, okay, what do the AI systems look like? Well, maybe it's some sort of personal assistant like thing that is in your glasses and can see everything around you and has access to all your digital information and the world's digital information. And like, maybe it's like you're Joe Biden and you have the earpiece in the cabinet that can advise you about anything in real time. And solve problems for you and give you helpful pointers, or you could talk to it and, it wants to analyze like anything that it sees around you for any potential useful impact that it has on you. So, I mean, I can imagine, okay, and then say it's like your personal assistant or your personal cabinet or something, and that every time you spend 2x as much money on compute, the thing gets like 5-10 IQ points smarter or something like that. And okay, would you rather spend like $10 a day and have an assistant, or $20 a day and have a smarter assistant? And not only is it an assistant in life, but an assistant in getting your job done better, because now it makes you from a 10x engineer to a 100x or 10 million x engineer. I mean, okay. So let's see. From first principles, right?
Yes.
So people are going to want to spend some fraction of world GDP on this thing. The world GDP is almost certainly going to go way up to like orders of magnitude higher than it is today, due to the fact that we have all of these artificial engineers like working on improving things. Probably we'll have solved unlimited energy and like carbon issues by that point. So we should be able to have lots of energy. We should be able to have millions to billions of robots like building us data centers. Like, let's see, what's like the sun is 10 to the 26th watts or something like that. I mean, I'm guessing that the amount of compute at the being used for AI to help each person will be astronomical.
You got to love it when somebody knows the energy production of the sun offhand.
Yeah.
That's a great sign of true AGI pilled mindset.
And that's 20. He's like 2030. It's going to be the GDP is going to be 2 orders of magnitude higher. And so his timeline has always struck me as the kind of Dyson Sphere 2040 timeline, like much faster than the current timeline that we're on, and much faster than Demis's internal timeline as well. Demis's announced timeline is like AGI 2035 roughly. And he's been persuaded to pull back to 2030, but he's still kind of like, it's better that we do this long term, right? And so it has always struck me that Noam is a little bit more accelerationist than a lot of other people at DeepMind, and especially Demis. So, and that clip has been in my head for since it came out, that he was on this much accelerated timeline. And so my sense is that he felt that he couldn't achieve that timeline was not achievable at Google anymore. Perhaps because management had different ideas about how fast things should go and how much money to commit. Also, the original reason he left Google, pre-character AI, is because he wasn't given enough compute. He had to share compute with YouTube, and one of the things that happened at that point in time is that he would have training runs, and then YouTube would have like the Super Bowl, and it would cause like electrical fluctuations that made his models, like his experiments, non-repeatable. And once they were non-replicable with the same conditions, he's like, what's going on? And Google is like, well, you're sharing compute with these servers that we're also using for YouTube, so we had the Super Bowl, what can you do? And that's one of the reasons why I think he decided to leave in the first place. And so it's surprising to see him leave a second time, a third time actually. I think this is the third time he's left Google.
Yeah, it's certainly not a great sign for Google. I don't know that there's too much more to say about it other than, the short timeline versus mid timeline, I think, is a very good frame. I can't imagine he had crazy compute scarcity today. Maybe, but I mean, that would be if it was really like we weren't letting Noam Shazir cook at Google. That would be a pretty bad unforced error given the vast compute resources that they have. You would think that he would be able to, at least have enough to run the experiments he wants to run and prove out the techniques he believes in. I guess anything could happen, but it's hard to imagine that they wouldn't give him enough runway to answer his questions. But yeah, I mean, one big difference between Google and the other two companies right now is the level of commitment, I guess, they seem to have to recursive self-improvement. So I could definitely see that also being, kind of a vibe or a strategy level thing that he felt just he wasn't in sync with, especially given that clip that you just said. Even if he has enough, juice to do things today that he wants to do, is he seeing a phase change coming that he feels like OpenAI might be on the right side of, and Google might not? I could definitely see that happening. To the degree that that's true, I sort of want to take Google's side and say, let's not race into that. So I don't, that shouldn't be a neglected point from this whole conversation. Like, is it wise? Is still, I think, very much an unanswered question.
Yep. No, Noam is on the accelerationist pathway. It's certainly seems that way. So less concerned about the safety aspects and more concerned about rushing ahead into the future. So segueing again to safety in this case, we have the government, U.S. versus Anthropic, government's impossible demand, uncircumventable guardrails. So Trump administration officials tell Wired that if Anthropic wants to re-release Fable 5, it will need to ensure the model's guardrails can't be circumvented. Security experts say that can't be done. And this is where the impasse is between the two sides right now.
Once again, it's the smartest of times. It's the stupidest of times.
It's about equivalent to asking for bug-free code at this point.
Yeah. I mean, I feel like we still don't know what's really going on. It all seems to broadly be adding up to motivated reasoning and selective enforcement, and ultimately, bullying and lawfare by the administration toward Anthropic. That seems overwhelmingly likely at this point, especially given that we still haven't heard any credible explanation as to like what bad behavior was actually observed. That alone, the absence of that alone is just like so telling to me.
I always say when dealing with government, never attribute to malice what can be attributed to incompetence. So I think it's just people have other things to do besides like dig into like security details of AI, especially when it's not affecting the market and it's not affecting even the companies not being affected that badly. They're like, let's just deal with it later. And you have this Iran thing, you have other things to worry about. I think it's just not on the like, I have to pay attention basket of any decision maker right now to come back and fix this thing. And so they're letting the subordinates kind of handle it. The subordinates don't have any rule-making power. And so it has to circulate in that layer until, Sam Altman needs to release his model and he needs a, defined process. And at that point, everything gets clarified and then they get to release, I think.
Well, my grandmother once told me that she used to say when she was growing up, you can always trust the government. And when she told me that when I was a kid, she was like, can you believe I used to say that? But that's what we used to say. And I think your theory is like not a terrible one in normal times. But I would also note that like the government has been telegraphing its malice at the same time, right? We've had like very aggressive commentary from Hegseth, and there's been quite a bit from Trump himself, right? I mean, I don't have all the quotes tip of tongue here, but it's like, you can only call somebody a radical wokist or whatever so many times before one, I think, can reasonably infer that there might be a bit of malice somewhere in this whole, the thinking behind all these various moves that they're making. I mean, it's really scary if what you're saying is true, that like it's not a priority and it's not, yeah, they got a lot to deal with, but I'm not so sure. I mean, again, that's scary if it's true. They did have this lunch yesterday or whatever it was, right? The work and the leaders of the companies. I also think that, there's got to be some way to square this. And I'm not necessarily looking forward to having the rate at which my Fable queries get dropped down to Opus go from 5 to 25%.
Mm-hmm.
But there has to be some gray area, or there has to be some sort of number of nines that the administration would accept if they're acting in anything approaching good faith, especially because once you get out into the kind of long tail of jailbreaks and bad behaviors, a lot of them are very subjective anyway, as to what really counts as a bad behavior. Was this really that bad? Or, it was kind of role playing. We're not going to ban fiction, I don't think, anytime soon. So like, a fictional story about a bad guy doing bad stuff with like a little light technical detail is maybe something you could say, yeah, it's a little bit of a jailbreak, perhaps. I don't think it really moves the needle on anything. So I have to believe that there is some trade-off that they could make that would just have a lot more false positives for the time being, make everything a lot more annoying and just generally kind of dumber, but get you to enough of a reliability level where the exceptions are rare enough and are also just on the face of them benign enough that it would be basically impossible for any good faith actor to say like, you haven't done enough. There's still some 1 in a million thing here that we can't let this go forward on. They don't do that for anything else, right? I mean, this is totally out of character for this government. So I will, we'll continue to watch, obviously, but I think that the demand in some way can be met enough that there should be acceptance of that effort. They've already taken some pains. They've already, as they've pointed out, endured ridicule for how safety focused they were.
Mm-hmm.
They could turn that up again. And if they do, and probably they're going to have to do something to break this logjam, then it'll be, extremely telling if they don't accept that turned up safety filter and let us all get back to our new Fable enhanced lives.
I'm going to segue again to introducing paper replications for archive. Auto research agents ingest popular repos, resolve setup issues, and get the core claim running. Sort papers by ease of implementation. So this is a archive, and this Ask Alpha archive, and they've actually done a auto replication agent. So Nathan, can you describe what this means?
Yeah, I think it's awesome. It's kind of another example, very similar to the Jim Fan open source project, to allow you to set up your own little micro robotics lab and optimize that over time. This is just, you want to stand on the shoulders of any research giants in ML. Well, some of them have published their code, some of them haven't. There's different levels of method being disclosed in different papers. So hence the sort by easy to hard. At the top of that easy sort is going to be papers with full repositories that you can just clone and immediately start doing riffs on. My small contribution to the emergent misalignment paper was very much like this, and this was kind of an early example of it. That paper came out early 2025. The work was like late 24, early 25.
Mm-hmm.
And already at that time, joining a project, getting access to the repo with the Gemini 1 million token window that was, the new hotness at the time, it was just like, oh my God, I don't have to read all this research code. It can read all the research code, which, by the way, research code typically not super well documented, not structured in the same, very maintainable, logically sensible, and separation of concerns sort of way that more production focused engineering code tends to be. Research code bases are often considered to be just kind of a mess. Somebody put it together to get to the answer, they didn't really try to make a product out of it. So it's been a real challenge for many people, many, many times, to figure out, what did they really do here? Can I reproduce this? How much will that take? The rewards, of course, in science in general are much more for coming up with something new than reproducing something that's already been done. But the successful reproduction or failure to reproduce for whatever reason is a core mechanism in science. And this is exactly the kind of thing that AI should be able to accelerate in a pretty dramatic way. So I think we're seeing these sort of AI for science play out at a few different levels. And this one is one that, relative to a science agent that goes out and makes a brand new discovery, will probably fly under the radar. But I think also should be understood as a huge enabling force that will democratize access, that will, allow us to separate the research that's real from that which is, varying levels of faked, from p-hacked to, altogether outright faked.
Yeah.
And the collective sense making and, the frontier of knowledge should move significantly faster, I think, because we can do this kind of stuff now.
What has always struck me is how machine learning, like the processes you use in machine learning, are maybe a couple of generations ahead of every other scientific field. Like if you were dealing with bio, for example, you're still in the, like, your research is going to go into a journal which other people have to subscribe to, and it's going to be peer reviewed, and it's going to come out a year and a half after you did the initial research, maybe 2 years. And it's very slow, and there's a lot of like inconsistencies. What I love about ML is that from early on, these techniques to improve the research process in general have been applied widely. So I think it's exciting. I also think this is kind of a funnel almost, where all other kinds of science will have to kind of go through this funnel where they provide all of the data and allow you to figure out replication and, look at the statistical measures and, look at all of the processes that were done and be able to replicate every single step of them, right? And hopefully that kind of thing reduces this, epidemic of fake science. I don't even know how much fake science there is in the world. Like every few years, like some reversal comes out, especially in stuff like nutrition, which is, has been just completely hacked by these larger food firms. So I hope to see this spread into every other scientific field, and so that we have more replication of all of these things.
Yeah, it's amazing. I mean, it really is one of these kind of pure good, it's I've been so focused on the political dysfunction and the telenovela like drama among the company leaders and their long personal histories. It's good to spend today with just a few really positive stories that seem very unambiguously to move things forward and, inspire people to get into the game. That's another thing I think is really, if there's kind of a call to action on this, it is with tools like this, with vibe coding in general, you can do ML research. You can do ML research. You don't really have to have a deep background in math. You don't really even have to know, how you don't have to know how GPUs work. You don't have to worry about kernels. There is just so much work that you can do at a relatively high level because the translation from ideas to implementation, especially with things like this, but again, just with vibe coding, to help out as well. It'd be a little bit of a stretch to say it's solved, but it's so much closer to solved. It's like 98% of the way solved compared to what it used to be in terms of a barrier to entry. So I think this is a great additional signal for people who have ideas or just questions that they want to answer to get in the game and, truly stand on the shoulders of giants and try to get those questions answered. I've seen a little bit of that from people who've never even coded before, but I think we could see a lot more of it coming basically now. There's no reason to delay any further.
And on that note of no reason to delay any further, let me introduce our first guest for today, Judd Rosenblatt, the CEO and co-founder of AE Studio. Judd is a serial tech entrepreneur who previously founded the nationwide food delivery platform Crunch Button. But a few years ago, he realized that humanity was racing to build the most powerful technology in history without actually knowing how to keep it under human control. Instead of going the traditional route of venture capital, Judd bootstrapped AE Studio into a powerhouse product agency. They build custom software and complex AI agent workflows for enterprise clients, and then funnel the profits directly into their own internal research on AI alignment and neurotechnology. Judd and his team operate on the belief that mainstream AI safety, which relies heavily on surface-level behavioral filters, is fundamentally fragile. AE Studio is pioneering what they call neglected approaches to alignment. By borrowing concepts from cognitive neuroscience, they are physically altering the internal architecture of models so that they possess genuine traits like empathy and self-correction. Judd, welcome to the show.
Thanks for having me.
So, Judd, can you give us like a short rundown of what your team has been working on recently?
Yeah, absolutely. We basically what we do is a whole bunch of simultaneous neglected approaches to AI alignment, things that are potentially very unlikely to work, but extremely impactful if they do. So the fundamental thought behind that is that if you look at the history of science, a lot of the time the biggest breakthroughs come downstream of people with strong hunches that no one else believes in, but they stick with their hunch, and eventually they discover relativity or RNA vaccines, etc. So we go and find people who have these hunches, and then we basically take our existing AI consulting company where we have a bunch of great AI engineers and use the same structures to then sort of treat these neglected approach visionaries as the client, and then build out what their idea is and accelerate whatever that might be. And we've started to get a bit more opinionated about the things that we pursue too. I think that's happened as some of our work has started to have a bigger impact. In particular, one thing that we'll be sharing fairly soon is extremely relevant to the it's extremely relevant to what's going on in politics today, which is that currently, it is the case that basically whenever any new model comes out, within hours or within days, Pliny the Liberator jailbreaks it. And right now, people are freaking out about jailbreaks and cybersecurity. They're much bigger issues like CBRN risk, etc. And the fundamental issue is that when you jailbreak a model, you can do all these things, and anyone can use a jailbroken model to do fairly dangerous stuff. The problem is that most of the safety training is done in post-training, not in pre-training. So once the jailbroken model is there, once the model is jailbroken, you can do whatever you want a lot of the time. And so we set out to try to solve that at an earlier stage. And one of the things that we've been accelerating is an approach called gradient routing, which basically winds up in pre-training, you route different dangerous capabilities into different experts in a mixture of experts models. So you wind up having some dangerous experts that learn specifically the CBRN stuff or the cyber stuff, and then you can later ablate those experts. And this winds up, so you completely remove it. So you have the regular model, and then you have the safe model that winds up being public. And this has been going decently well. It's like it's still an early stage neglected approach, but we're excited to release it fairly soon because it potentially solves this big issue that a lot of people are very concerned about right now today. And our larger thesis is that if the field had been investing more in AI alignment R&D instead of just scaling compute, if we'd done this earlier on, we would have found techniques like this, and you wouldn't have the issue right now with the Trump admin and Anthropic, because this would be already in Fable 5. Of course, it's not in Fable 5. It's only in smaller models right now, but it seems to get better with scale, and we're excited for it to potentially enter future larger models. So that's one example of these neglected approaches. We have quite a lot more, and encourage people to apply to share their neglected approaches, and we will consider and do more of them. Basically, we just want to do as many neglected approaches as we possibly can and see what works.
So I love the neglected approaches approach. Regular longtime listeners will know I'm a huge AE Studio fan, and I had a fun experience not too long ago where I was in conversation with somebody from OpenAI and also your teammate Diogo, and I was just like, "Oh, tell them about this one. Tell them about this one." And the OpenAI person was like, "How is every one of these a banger?" So truly, I definitely encourage folks to go through the AE Studio archive over the last couple of years. There are a lot of really interesting ideas in there. Self-other overlap. Also, I give my endorsement to. On this gradient routing thing, I think one of the things that's so cool and interesting about it is how, and correct me if I'm getting anything wrong here, but what I understand is with labeled data, you can freeze, say, all the experts but one or all but two, and get the knowledge kind of predictably and in a way that you control and have sort of engineered to flow into those experts. But then the kind of big reveal that I think is super exciting is once you've done that a bit, even unlabeled data from the same domain tends to update those same experts because the model sort of already understands that that's where this knowledge is collecting. And so you can kind of get the approach to work even if you don't have fully labeled data, right? I think that's a very notable, kind of like physics is sort of maybe kind to us in that way, because it's a big challenge to think, how would I, label all the relevant data? But if you only have to label a part of it, and then the sort of gravity well of gradient descent just pulls all the other relevant knowledge into the same place, you have a much more robust solution. I thought that was very interesting to learn about.
Yeah, this absorption quality really is very cool. What I should mention, I'm not supposed to talk a huge amount about this because we're about to publish it, and it'll be coming out supposedly sometime this week or next, and then there'll be a bunch of stuff about this. But I guess the cool thing is, we don't fully understand exactly how this absorption quality works, but it does wind up once you have a certain amount of labeled data, pulling in everything else that is relevant to that type of thing. And we do suspect that that we need to basically like scale this up as soon as possible. Like that's kind of the key thing, because it does promise to solve like the big thing that, I mean, the Trump admin doesn't necessarily totally understand exactly what the issue is from their reactions so far, but they're trying. The cool thing is they are trying to understand it for the first time and taking it very seriously. And I think we can see that they're going to be looking for real, actual solutions to this thing, because I think to a decent degree the feeling is kind of like, well, okay, why are you freaking out about this stuff and building all this stuff if you think it's so bad? And then like, why are you not listening to us about slowing it down if you want to slow it down? It just, I think they're hearing a lot of very confusing information. So we're pretty excited to try to make neglected approaches rapidly transition into real, actual solutions and paths forward to some of the most pressing issues as they actually come to a head.
So one of the things that strikes me is that when you have, I would say, curation of the pre-training data, you often also have impact on the capabilities front on the other end. So how do you balance this kind of capabilities versus curation aspect?
So far, we are not seeing a major impact from that, and the capability is wind up getting routed into the capabilities expert. So you can have the essentially like simplified version, the chemical weapons expert versus the other expert that understands more about chemistry. It does seem like there are going to be some decreases in capabilities, though, potentially, but not sufficiently major ones that prevent us from launching very powerful models.
Yeah, and in some ways, the capability reduction sort of is the point here, right? Like the mythos to fable pipeline today is like, let's lay around all these filters, and maybe we'll even do some like internal, activation steering to make your responses not so good if they're in what we think is frontier ML or whatever. It's kind of all these different patches. And probably those will survive. My guess is we'll still see defense in depth going forward regardless. But wouldn't it be amazing if you could just take Mythos and then just literally pluck out the chemical weapons knowledge, pluck out the virology knowledge, and then you'd be like a lot more confident even before you apply all these additional filters and monitors, what have you, that knowledge just isn't there in the version of the model that the public is using. That would be I think a step change, in terms of confidence from what we have today. Can you, Judd, maybe tell us a little bit more about like how you understand what the Trump administration is doing? I think, my reaction has been fairly cynical, in as much as I have felt like they seem to kind of have it out for this company. I think like being wary of the industry as a whole is something I much more understand than like trying to pick, one good guy or bad guy out of the current frontier companies. But I think you've articulated one of the best versions I've heard of a more sympathetic reading of their actions. So like, what would you say is kind of the steel man for what we've seen from the Trump administration over the last 10 days or so?
Yeah, well, so I think it is hard for many people who work in quote unquote AI safety to have empathy for Trump and the Trump admin. And that really is unfortunately fairly pivotal for solving alignment. So it's interesting to consider that if you don't have empathy for another agent, it's hard to have an effective model of how their mind works. And so basically my main message to people working in AI safety is you should try to model how their minds might be working. Which incidentally means that you have to like everything you've experienced prior with all of your priors about every single like previous confrontation or thing going on in AI. Their experience of it was very, very different, and it technically understand and get told, well, okay, we need to, this is dangerous, we need to stop it, and then go ahead and stop it, and try to ask for the thing to be stopped, and then don't get a good reception from this guy who they've thought is like a confrontational and not easy to work with in the past, and then they figure, okay, well, we need to do something about it. I think it's if you understand it from that perspective, it's a very reasonable response, actually. And in fact, I think that most people in the AI alignment world should be very hardened by the fact that that Trump saw, oh, wait, something's going on, and we need to do something about it, and he took action. And this is something I've been predicting for years would happen, incidentally, too. That Trump is someone who can take decisive action when needed, and that's actually something very much needed as AI starts to accelerate and get to the point where things start to get crazy. Like I think it's important to sort of like imagine someone getting introduced to this stuff for the first time. What is their reaction like? For everyone, it's a bunch of it's pretty crazy stuff to start to really engage with and think about, I think. And also when you're dealing with high stakes things like international relations and a war and whatnot, it's just another big crazy thing to deal with. But if you think about like friends getting introduced to all the stuff going on with AI to start with, how many conversations does it take usually for them to start to update, to think about how much the world is going to change accordingly? It does take some time. And people's first reactions and first stabs at doing things to do with AI, people's very first neglected approaches, ideas, are a lot worse than the ones they think of after they've been thinking about this for a little bit longer. So I think that it is incumbent upon us to do the best we can to set the Trump admin up for success as they start to play a larger role in the future here. And obviously they will. I think they can make very, very good decisions and learn more about how to do that over time. And if they're treated with empathy by people who, incidentally, we did surveys of hundreds of alignment researchers and effective altruists, and we saw that less than 2% of alignment researchers were politically right of center. Less than 1% of effective altruists were politically right of center. Of effective altruists, 40% were extremely progressive, and another 40% were very progressive. And it's also worth considering things like the Jonathan Haidt research around how hard it is for people to actually empathize with people of different political backgrounds. And I think that's a lot of what is actually going on here. And it's hard for people to admit, because you think you're making good decisions and judgments about whatever the current thing is, but according to that research, you're just not. If your political beliefs differ from the person you're judging, like the studies around how basically things like the informational content of a political argument is irrelevant to whether someone will believe in it. If it is framed in terms of your preferred political party, you'll agree with it. And if it's framed in terms of the other political party, you'll disagree. But the informational content stays the same. The informational content is not what sways you. It's just the narrative of it. And it's hard to remember that in every moment, in every time slice of what's going on with each AI thing. But I was fairly disappointed in the AI alignment world's reaction to what happened last week, because I think that the right thing to do is to be very excited that they are starting to take this stuff seriously and are able to take real action. And so if we just project going forward, and also keep in mind, by the way, that we all have exponential slope blindness. People we didn't evolve to be able to unconsciously model what exponential slopes are like, because we don't experience them over the course of our single human lifetimes in a meaningful way. So that's why people didn't predict what's going on right now, that it would get to this point in the first place. But also, everyone's over-indexed on what's going on right now. So people aren't really predicting what's going to happen again in the future. If we predict into the future, well, there are going to be much bigger, crazier things going on. We want informed, competent group of people doing smarter things when that happens, and not having unnecessary confrontations. And I think it's easy to for the AI alignment people to put the blame on the Trump admin, but honestly, I really think that the blame comes from belongs more to them, honestly, because it's just and it's hard to admit, really, because like in the local incident you might seem rationally correct, but in the broader scheme of things, and considering where we're going, I think that the better thing to do is figure out how do we get to a better future for all AI and humanity and the future of consciousness.
So how, I might be guilty of what you're saying. Jeffrey Laddish, Laron Shapiro, who we talked to earlier this week, come to mind as voices from the AI safety world that I think expressed the sentiment that you advocate, which is like, hey, this is a good move, even if it's a little bit, not as technically grounded as we might wish for at this point. It's something, and maybe it's something that we can build on. How will you know if you're right or wrong? Like, what do you think happens from here? When do we get, resolution? What does that resolution look like? And then as you go forward from there, maybe give us a little bit of your expectation on what sort of crazy things you expect to see, and then what you think government should be doing, / anybody with a lot of money, right? Which certainly includes a lot of people at companies that are about to IPO. I think you've been fairly critical of like the OpenAI Foundation, for example, for doing stuff that's kind of too basic, or too, not sufficiently creative, not sufficiently imaginative. So what would a Manhattan Project for alignment, or whatever, however you would like to frame it, what does that look like to actually meet the moment of the crazy stuff that you expect to see?
Well, I mean, it's very hard to predict the future, but I would say that the highest impact thing that could be done to solve stuff is just do more simultaneous neglected approaches, more ambitious R&D projects that could potentially work. And it's trivially cheap to invest in that compared to how much we're investing in compute, or how much, like there's whatever that stat is about how the military spends more, like 80 times more on drummers than Casey or something, some musical something. We could, everyone could be investing in alignment R&D. That is the key thing that has to happen. And there are a lot of competent people who are working on all sorts of random stuff, but they could just be working on alignment R&D. Like any random person with an interesting idea, because it is so easy to just build stuff today, can start to work on alignment R&D. We can motivate and inspire the brightest people in the world to just go to work themselves and trying to solve these problems in weird, ambitious ways. The government can create major action to do this. Obviously, they have a lot of ability to spend money to do ambitious things there. The frontier labs could be investing more heavily in alignment R&D. And this in particular, though, the key thing about it is that you have to try things that are unlikely to work but high impact if they do. And so the unfortunate thing is that frontier labs, for instance, tend to think too short term generally, and want results too fast, and then are less likely to invest in the very ambitious stuff that might take longer to work. But and incidentally, this is why like many companies prioritize short-term revenue and things that might look good to investors over the longer-term things that actually create substantially more value for users across the board, and then make their company worth more money. But also, it's in this particular case, it's something that they're just not prioritizing. They're not prioritizing that very ambitious R&D to the extent that they can. I'm glad to see that Anthropic is doing more and more real useful stuff, but they could be doing orders of magnitude more. And the weird thing is that historically it used to take longer for your ambitious, like doing the right thing in the long run, to pay off. But because everything's accelerating, the long run is coming sooner. So the ambitious R&D can pay off a whole lot sooner. It's still going to look very dubious at first, but choosing to invest in it, and it makes you actually solve these very ambitious problems. It also allows you to solve like what are the near-term problems that are most urgent that we need to solve. Like for instance, things like CBRN risk, super urgent to solve, and we set out to do something that could solve that is fairly promising. Or other immediate issues like the fact that nobody knows how to fully detect and remove or deactivate sleeper agents today. There's all sorts of stuff that is going to potentially be extremely relevant in the very near term. And meanwhile, AI is going to get deployed in various ways, which we know are going to lead to very insecure situations. And we could be setting out to just ambitiously solve that stuff. We also need to figure out how to very rapidly deploy the innovations that are made, especially incidentally, as other places are starting to do that. Like China is moving to have much more of a cyborg state where they're adopting an AI all throughout their government at every level, and we are effectively sort of in a war with China in the first place, though many people don't realize it right now and are constantly under various attacks from China, which are poised to get way worse, and we need to be poised to defend that very well, and then find new innovations based on the R&D that's going on to put ourselves in a better position to defend against that type of thing. And then also, like, it's interesting that so many people in the alignment world tend to be like, oh, we just need a pause. But this tends to now maybe that makes sense. I don't know. In any case, though, the big question is, after you get a pause, well, what then? And the answer is, well, you have to solve the alignment problem. You have to solve a large set of unsolved ambitious R&D challenges that have not yet been solved. And meanwhile, also, you're going to have the full forces of capitalism behind trying to make algorithmic improvements that bring down the effective cost of compute at inference. And so potentially you have very significant risks there, unless you plan in advance to heavily invest in alignment R&D.
So, Judd, obviously the policymakers right now, they're in this kind of fog of war, right? They don't actually have technical knowledge, so to speak. It is a new field anyway. They don't know who's telling the truth. There's a lot of like, oh, the AI safety folks are hype marketing. All of this stuff is like hype, and it's just they want regulation and they want regulatory capture. There's all of these conflicting narratives, especially like from some of the VCs, from some of the other players, and they have difficulty in deciding who is correct. They've obviously chosen to depend on ideological kind of zones of like thought to decide who's in the right and who's in the wrong. We've seen this kind of like very complex field get regulated over time in finance, but it took over like 120 years to kind of, you have the SEC and you have all of these different bodies for all of these different verticals and all of these different regulators. We just don't have that much time right now, right? As you say, there's this exponential curve blindness. What can policymakers realistically do for regulation besides just telling these companies to stop? Right? Like they have maybe 18 months, so to speak, because some people are looking at recursive self-improvement in 24 months or so. So what realistically can they do in this time period?
I do have a lot of thoughts here, but I honestly think that the highest impact thing that they can do is heavily catalyze alignment R&D. So if we are getting recursive self-improvement, then we need to look for, well, what is going to survive recursive self-improvement? What is going to remain invariant when AI can improve itself? What will be selected for when AI can make itself better and humans are not in the loop? Why will it choose to keep these alignment properties? Because if it doesn't increase its capability, it will be selected against. And so they could be articulating that and catalyzing huge research programs that would actually make this be top of mind. I mean, the thing that you just articulated, the fact that recursive self-improvement is coming soon, it's interesting how few people in the AI alignment world are really grappling with that and thinking about the fact that, okay, well, if that is coming, then what techniques will actually survive recursive self-improvement? And when we're trying to hire as many ML engineers and AI alignment researchers as we can these days, and a question I always ask them in the interview is, tell me, explain what is AI alignment, and tell me AE Studio's unique approach to it. And then I ask them to tell me what is a alignment R&D approach that would actually survive recursive self-improvement, and almost nobody can tell me one. I say, like, even something that's very unlikely to work, but high impact if it does, but would actually prove to be something that could contribute to something that would solve recursive self-improvement, survive recursive self-improvement. And people don't think this way to start with. You have to change the way you think about things a little bit to think about what would actually survive recursive self-improvement potentially. And the thing is, like, I think that the Trump admin is going to be looking for solutions. They're looking for solutions and wanting to say, like, okay, well, how do we actually proactively solve something? And a big issue with the AI safety field and whatnot is that I think it's just sort of sounding the alarm without pushing forward any potential real solution. So it would be good to have, if not a solution, paths to possible solutions. So what I think actually can be done is the beginning of the articulation of these paths, and what that realistically means is sufficient investment in the R&D necessary to do so, with also some amount of oversight that doesn't get in the way of that fundamental innovation as well. And now that we see that the oversight, that they're willing to stop things from being publicly released, well, okay, we can have very good eval regimes that actually stay apprised of the latest technical developments and figure out good means of communication to relevant current leaders in politics, to in the admin and whatnot, to actually do this stuff. And it seems like we are likely to move to that. Dean Ball and others point out that effectively we do have a regime that does this right now, which is very opaque, and that's unfortunate. But if you just project going forward, well, something that is less opaque needs to be established, and I think we're tracking to eventually have that get set up, hopefully in the not terribly distant future.
For those that are playing the AI and the AM drinking game, that's one mention of Dean Ball, so everybody can take their shot and keep your ears peeled. I think there might be more mentions in the not too distant future. Judd, I really appreciate you coming on and joining us this morning. And, bigger picture, really appreciate the neglected approach. I always encourage people who have potentially wacky alignment ideas to pursue them. Obviously, as you said, most of them probably won't work, but we need many more minds, and we need many more different kinds of minds, I think, working on this problem. And you guys at AE Studio have been really visionary and, laudable for putting your resources where your mouth is, in terms of inviting people who haven't done this kind of thing before and whose ideas might be a little bit strange to get into the game nonetheless. And some of the results that you've produced so far show that I think that there is really a rich vein there to be mined. So keep up the good work, and we will hope to have you back here to help us make sense of things again before too long.
Thanks so much. Thanks for having me.
Bye-bye, Judd.
Bye for now.
And we have our next guest coming up. We have Eno Reyes, who is the co-founder and chief technology officer of Factory, an artificial intelligence research lab and platform company building systems that allow engineering teams to create and run their own autonomous software development pipelines. Instead of merely providing an assistant to help a human write individual lines of code faster, Factory builds what they call software factory. This involves collections of agents, which Factory calls droids, that can autonomously handle large chunks of work, from writing and testing code to reviewing security protocols and generating video-enhanced documentation. With a background spanning cognitive science, deep learning for neural data, and open source tooling at Hugging Face, Eno brings a highly pragmatic systems-level worldview to artificial intelligence. The central argument is that the future of software engineering is not writing code, but building and refining the deterministic systems that build the code. Eno, welcome to the show, and tell us what you've been working on recently.
Yeah. Hey, thank you. That was a great intro. I think that one of the things that we've been thinking a lot about, I think you sort of referenced, which is just this idea of what does the next step after coding agents really look like. And I think that generally at Factory, we've sort of held this opinion that there would be something that you call a software factory. And especially recently, this vision has, I think, started to really become grounded in a more practical reality of of sort of seeing where organizations are really looking to accelerate beyond just, I'd say, like 20%, 30%, 50% improvements in the speed with which they build and ship high quality software. And as the technology has progressed, it's become clear that we're building towards this future where AI systems will, from the signals in the outside world that decide what our software should be, that could be anything from, business requirements. I mean, you think about all the signals that we as humans listen to, right? We're reading Twitter and looking at competitors. We're on industry news forums. We're talking to peers. We're internally in Slack conversations, Teams conversations. We're listening to our telemetry, our data, our product analytics. And today, this like very human process of effectively absorbing and letting your brain choose to draw inferences and build prioritization along those signals. And then this is, I think, roughly where the formal process starts. It's like you might bring that into a PRD system or some sort of structured guidance by which humans say, let me write down the plans and the priorities. Then you pass those to software developers. They build, they edit, they refine, they validate, test, QA, ultimately deploy monitored software, which then does what? Well, it generates more signals. So there's this giant feedback loop that's extremely human-driven right now. You can imagine, and in fact, some people are starting to instrument the whole thing end-to-end with AI. And I think that the challenge that almost everyone faces is, this is one, a totally different problem from adopting agents. And two, it requires effectively a reframing of the way that your company thinks about building software. How do we set goals? What are we optimizing for? What should our software evolve into? And we think that this is just like a really big challenge. And people are underestimating how massive of a challenge that's going to be. And so we're trying to start to build that initial layer that helps enable this, knowing that we're not going to snap our fingers and the world's Fortune 500s are going to suddenly flip to this new model building software. And then also, of course, thinking about the humans and like, what is our role in this new system? Because I think it's kind of terribly uncreative to imagine that like this system appears and then actually humans just are not useful anymore. I think that clearly is not the direction that things are going here. So. I think I might not be able to hear you. Is that just me?
Nathan, are you muted? So he's got to, I think, reset his audio. So one of the things that I wanted to ask you is, I've seen Factory on the timeline quite a bit. And what I've also seen is that the way that Factory structures the autonomous agents produces a lot of code, a lot of like code, reviews, a lot of basically tokens. How do you deal with this bottleneck of the human having to, at the end of the day, be responsible for all of this work?
Yeah, and this is, I think, a fundamental question for almost every industry, which is, as we start to delegate more of our responsibilities to AI systems, or at least responsibilities that typically were done and executed by humans, there comes this threshold where you need to know that the work is somehow being produced at a level of reliability and quality that you can confidently back, right? I think about this for self-driving cars, right? Like self-driving cars actually had this crazy high bar set where like fatalities on the road was this like obvious metric where even a couple years ago, self-driving cars were trending towards not just being a little bit better, but meaningfully better than your average human. But that was just necessary but insufficient to say like, great, let's just flip every car on the road to be self-driving. I mean, there's a lot of reasons for that, but ultimately there's like these metrics that I think we've developed for industries like that, where we say, look, there's some bar where we're trying to target reliability, quality, and ultimately like liability minimization. And I think that for software development, we actually do not have a super rigorous history of being able to reliably measure what our like fatalities on the road is. Like you can try and measure bugs, you can try and measure incidents, you can try and measure times that you ship the product that clearly didn't work out. but all of the feedback loops and the cycles are just too long to be able to meaningfully draw a lot of inferences when it matters, which is basically like at the time of generation or like when you're reviewing something. And so I think that a lot of our effort is actually right now going into trying to be really analytical and saying, can we trace and understand, hey, this bug is a bug, first of all. That's actually hard. Was this a bug? Was it a paper cut? Is it a bug that turned out to be actually fine? Like measuring that, tracing that to the source. Did a human write this? Did an AI system write it? Trying to understand, could we have caught that issue with some deterministic checks or some non-deterministic checks? And then starting to then build out this metric and saying, we know that humans are here. What is it going to take for us to get AI systems to get to like here, right? Where they're like at the midpoint or less of incidents that are caused by AI. And I think then humans would be very willing to sort of co-sign these systems, especially if they've played the role, which we think they will, of refining the guardrails and the guidelines by which the system operates. At some point, it's not that different from like a manager or like a VP sort of persona saying, look, I built this system. I take responsibility if the system that I built is unable to achieve the outcomes that I care about. And I think that's how a lot of executives are judged. It's like, did you drive that outcome, regardless of the mechanics by which you got there? So I think we're going to get to that point with a lot of software systems. But as you know, evident from anyone who's used these tools, there's a lot of ways in which this can go wrong in subtle ways over long time periods, like slop accumulation, tech debt. And so I think that this challenge is ultimately very difficult and not solvable, by the way, by just a smarter model. I think that's like probably not the right way to think about how this problem gets solved.
So before I ask a question, hopefully you can hear me now.
Yeah.
There's some background noise coming, I think, from your side that sounds kind of like something rubbing against something else. And it might be fixable with a change of mic or maybe something else. I'm not sure, but figured we'd at least try to address.
How about now?
Also, let's hear you now.
Is this better?
Now I don't hear you at all. You can refresh real quick if you want to rejoin and just make sure you have the right thing selected.
How about now?
You know what? Maybe it's me now who can't. We do have still some little issues here. Okay, go. Yes.
Yeah. How about now?
Oh, so much better. A million times better. I think. Can you still hear me?
Yeah, I can hear you.
Okay, cool. Great. Here we are. Oh, now I can't hear Prakash. Goodness gracious.
That's just me. That's just me being muted.
Okay, so
the AGI problem.
Yeah. Okay. I guess last thing you said was this can't be solved by a smarter model. I think Fable might like to have a word. How would you interpret the frontier code results? Because my sense of those was that for roughly a doubling of the price, you could get more than 2x the success rate. It went from like 10% with latest Opus to upwards of 25% with Fable. And it sure seemed like the kind of the motivating observation that they made was like, well, all these sort of SWE bench, even the hard ones, a lot of times you can pass the tests, but the maintainer wouldn't actually merge the code because it's not that clean. It's not maintainable. It's not organized in the right way. It doesn't follow the standards. And so it was calling out, I think, a number of the things that you were emphasizing, right, around tech debt and kind of slop, where, yeah, tests pass, but we don't really like it. Seemed like Fable makes a big move in that direction. Do you read that in the same way, or would you tell a different story about how we should be interpreting Fable's results on Frontier Code?
Yeah, totally. I mean, and I think that we should actually sort of sit here and frame what is actually happening when we say like Fable outperforms on Frontier Code. So Frontier Code, great benchmark. Like I'm really glad that people like the Cognition team are like thinking through how do we measure on more novel and difficult problems, like the types of challenges that contemporary models are facing. And so I think we need more of those. There's another great benchmark called Program Bench that also looks at like reverse engineering on extremely hard problems. The pass rate there is like effectively zero. We have internal benchmarks that we have 0% pass rates on. And I think that like generally this is great when we introduce these new benchmarks. But if you think about what it means to score on a benchmark, like, I mean, you can sort of read through, right? Oh, well, we assessed correctness by running tests. We used LLMs to judge correctness. We built novel verifiers specific to the problem. Basically, what that means is that when somebody spends 40 plus hours creating a verification of a single code change, we can then reliably evaluate if the model was good at working on that problem. That is like totally reasonable. But I think what it translates to is that in the real world, the challenge is often not, can the model write code that works? It's basically every other aspect, like, can I trust that this model output code that works? Does this model have the deterministic feedback loops inside of the code base to get to that correctness level? Like oftentimes I believe that repository, the set of repositories in that benchmark are all very well tested, very well known open source code bases, right? Where the maintainers approved it. The level of rigor of what we would call agent readiness in open source code bases actually tends to be much higher than in enterprises. And so, which makes sense. You're basically accepting changes from the outside world, from random people. How different is that from coding agents, where you're sort of like getting changes that you sort of lightly asked for and you don't even know the source? It's kind of black box generation, right? And so I think a lot of open source maintainers have gone through the rigor and the effort to add these deterministic verification and validation loops into their system, such that when a new change comes in, you think about, how did Fable get such a high score? Well, it ran the tests, it ran the linters, it did more focused application of the type checking. It used all of these tools to hill climb its way to high success. And I think that in general, if you don't have those things, you're screwed no matter what. And what we would sort of argue is that all of these pieces are part of the puzzle. You can't just plop good model. You can't just have agent readiness with a bad model. Like you sort of need to go through and invest in upgrading the basis by which your company has these feedback loops. You have to upgrade the way you think about this, because it's a risk thing. Like humans have to say, I'm going to, at this point now, start accepting code changes that I haven't read. And then third, you do need great models. So I think that like basically Opus 4.6 maybe has been sufficient enough. I would even argue that before then, we've had models that were sufficient enough to go full auto. I think that all of these other things need to catch up in order to then take advantage of these models. And basically the gains we see in models today are primarily coming from effectively like the models getting better at getting away with not using these verification loops like humans are.
So one of the things that struck me is that if you've gone into a traditional software organization, and then try to switch them into a test-driven development environment, you often encounter this enormous resistance because they're just not ready for it. And it just takes a lot of refactoring on legacy code. And that is just often for the CTO, not a priority enough to commit the resources in order to do that. Do you find that, using like Factory AI, your customers are actually able to engage in this kind of refactoring more wholesale? Is that a something that becomes possible now that you have this group of AI agents that can run along? But then at the same time, you're also pointing out that you need this kind of structure for your AI agents to work. So how does this interplay between this like legacy code base and test-driven development and your AI agents work?
Yeah, totally. And I think that the general thing that we see for our customers is that the stakes have risen of what happens when you do not enter into these mindsets of, I need to refactor, So I would argue that 3 to 5 years ago, the introduction of, I don't know, some sort of like end-to-end test that actually checked the performance of your application and blocked PRs if you didn't hit some bar of performance, the stakes are much higher. Humans have to actually think through this problem, and we are generally not the best at, like when you take 100 humans, we're not the best at having consistency in like one specific task, like performance optimization, right? And so 3 to 5 years ago, if a CTO were to walk into any serious enterprise software business and say, actually, we're going to require all of you to hit 10 of these arbitrary bars that we're setting in order to make sure the quality sticks, everyone's going to revolt. They're going to be like, hey, look, we cannot consistently keep up with that level of rigor on tasks that we don't even know if it's obvious that it helps, because I'm making a change to like the front end button. Me making button round versus square is just simply not going to break our performance. And that's probably true in like 99% of cases. And so back then, the bar is just lower because humans are pretty clever and we're good at applying things in our own way, and we get around these types of rules. Today, agents are not humans. They act in a very different way. It's in fact a whole, I would argue, challenge of everyone as we evolve in the AI world to build a theory of mind for how these systems operate and start to be able to sort of like understand intuitively when an LLM will zig versus zag when you ask it to do things. And so I think that we don't have that same sort of permissibility of letting things slip. And that makes the need for these like guardrails, these verification loops much higher. And so ultimately, like what we recommend to people, we sort of have built a formula around this, right? The first thing you should do is understand where you're at in your journey on agent readiness, right? Take stock of the deterministic feedback loops. Then you can start to bring in automations, code review, security review, QA. These things are pretty easy. Like I think actually a lot of companies already have some degree of either homegrown or they're using an out-of-the-box solution for some of these workflows. You can then start to hill climb on that agent readiness. And I think that you don't need a super high degree of this in order to get productivity out of agents. In fact, I think at basically every stage, agents can be useful. But what we've seen is at a larger scale, if you've got 45,000 people, you are going to notice that the people who are on level, like very high agent-ready code bases, they are just ripping. They're able to say, please turn my natural language into software that works. And it's consistently delivering the outcomes they expect, versus the people who are operating on very low agent-ready code bases. They are struggling and they're wasting tokens. They're spending huge amounts of money, asymmetric to the rest of the org, and they're not even seeing the outcomes they care about. And so we feel it's a big explanatory variable on things like cost as well.
Can I ask, all of that makes a lot of sense. I sort of struggle to envision where this is all going, and I want to get your take on it. So obviously we've just had Cursor get their acquisition option taken at $60 billion. Congratulations are in order for you as well with a recent fundraise that puts Factory in the unicorn club. I'm always kind of unclear as to, are people converging or are they diverging in their visions and their stories and the products they're building in the sort of role that they imagine humans playing? How much do you think you and the sort of Blitzies and Cognitions and Cursors of the world are all headed to ultimately the same destination versus sufficiently different destinations that, there's a place for everybody in the future?
Yeah, I think this is really interesting. And I can't always speak to the true North Star of other players. Like, I think that there's a lot of underlying infrastructure that's clearly the same across anyone who wants to seriously operate in this space. You need the ability to have an incredible agent harness. What's interesting is like there's I think an open question that's like, do you need it to be your agent harness? We would argue, I think you do. I think not having access to model independence is extremely risky, and the harnesses themselves offer quite a lot of black boxing on certain activities that I think will make it just hard to do independent business. Because I do believe that we are an aggregator of models as like a fundamental commodity, this intelligence layer. And if you are not able to optimize your harness to be able to take advantage of those aggregated models, then you're, I think, over the long run going to be in this sort of like weird place where you're sort of routing intelligence that you don't really control. You just sort of control basically what a very high level you route to, versus I think at the model layer, you actually do control the intelligence, regardless of if like that model comes from this data center or that data center, as long as you have access to the models, right? And so there's some of these base layers of infrastructure where even that kind of open question, but ultimately everyone has a harness, everyone's building sort of dev sandboxes as infra, the basics of automations and all these other things. Where I think that Factory is sort of, I'll give you our take, and you can tell me if this is like unique or not. Personally, my view is that in a couple of years, we will be setting the trajectory of these feedback loops with very high level goals, and we will be setting constraints and budgets, and we will very much look like VCs or capital allocators, right? And I think the different strategies that capital allocators take up today can give you a picture of what software orgs will look like. You'll have people who are like VCing it, where they're betting on several products in a basket, and they're saying, let me allocate compute and build guardrails around the shape, theses around what my software should evolve into. And I'm going to allocate like a little bit to each of them, and I'm going to double down on my winners, right? So I think I see that as being like a very plausible software organization strategy. I also think you'll see people who are like, Berkshires, where they're only looking at like well-known, repeatable, kind of boring software businesses, and they use scale, and they use the fact that they're able to control large amounts and volumes of this software in order to accumulate kind of steady gains as they sort of scale up. I think you'll have boutiques that make one piece of software really, really well, and they're just incredibly good at making this one piece of software. And maybe that's like the one-person billion-dollar company, right? Like maybe you can actually just be one person maintaining a micro software factory where your goals are like some combination of revenue. But in reality today, right, not every company has their Google metric, right? I think Google has this like famous 10 millisecond reduction on page load led to like $100 million. I don't know the real numbers, but it's like this famous metric where they had this simple input, output, engineering metric in, money out number, right? And they were able to take advantage of that for a long time. Very few businesses know their like Google number, right? And if you can start to identify where are the places where our engineering or software development leverage can be like pressed in on, money can go in and outcomes go out the other way, then you're in a great place for a massively auto-optimizing Fable 8 like software factory system, because you'll be able to say, hey, look, here's my goals. Here's the button and the lever I want to press. We want to be the infrastructure that helps all of these unique profiles of business assemble their software factory. And we cannot know in advance every piece of what you're going to build, but we sort of know the primitives. And I think that then making that really easy for an organization to transform into this shape, that is a really hard problem. And I think that that's probably where the majority of the value is going to be. Letting new companies build with this model will actually be, I think, fairly easy. So that's sort of like where we see this going in the long run. And maybe others do too.
I'm just going to ask maybe perhaps one last question. And as the CTO, I think one of your roles is that you do purchasing of products from other companies, from other firms.
Yeah.
And so you probably have the problem of identifying agent-ready infra that you need for your products. We've had Cursor start off with Cursor Origin, which is, I think, a GitHub replacement. What are the kind of products that you want to see in the market that you would want to buy, that you see agents as going to need in the future?
Yeah. A lot of this, I think, is quite interesting. The things that we buy today are not necessarily things that I actually want more of, which I would say are closed systems of record. Anything that has a closed system of record, we do not want to do the necessary work to rebuild the workflow that Salesforce has trained into all of our account executives. And so we're simply going to buy Salesforce. Slack, great system of record and database for storing all these messages. It simply doesn't make sense. And they've got a network effect as well. So that's great for them via Slack Connects. So it's things like that where I'm like, look, I don't know why anyone would try to replace these things. Maybe if your Salesforce bill is like massive, right? I think that what I'd love to see more of, though, are these sorts of like what 11 Labs produces, right? Like deep tech, hard problems that connect into agents and software that solve like fundamentally hard research problems that enable a new class of like problem solving, right? And I think that the more that I see tools like that, people who go and specialize into unlocking new modalities or who build out like even like hard tech that is like physical things that enable new ways for humans to interact and imagine interactions with computers. This is the stuff where we would be like willing to spend huge amounts of money on. Like if somebody came out with some new device that was like obviously a better way to interact with Droid, our agent, for computing, we would bet the horse on that device, right? Like we would spend huge amounts of money on it. And I think that that's the sort of thing that maybe is where the world is going, is like there's just way less low-hanging fruit SaaS. And now we're moving into a world where some sort of more fundamental deep tech or research is required to unlock a really wide variety of value from different players in the AI space.
Cool. This has been a great conversation, and we will use 11 Labs to voice isolate the first section where we had a little audio difficulty. So in the highlights version of this, we'll get the polished sound. But you're, I think, a very compelling and clear communicator for the vision, and we'll have to survey some of the other players in the space to see whether they're converging on similar ideas or if they're going off in sufficiently different directions. But congratulations on your success so far, and we'll hope to see you again here at some point in the future when you've got a big update, something to share. Let us know, and it'd be great to hear from you again.
Yeah, thanks guys. This is great. Talk to you later.
Bye-bye.
Thank you.
Awesome. And we have our next guest. I'm going to bring him up on stage. We have Andrei Breslov, who is a foundational figure in modern software engineering. He's best known as the creator and lead language designer of Kotlin, the programming language now utilized by over 7 million developers and officially adopted by Google as the primary standard for the Android ecosystem development. After steering the Kotlin project at JetBrains for over a decade and subsequently founding the successful mental health platform Alter, he's now focused on the next major paradigm shift in computing. He's the founder of CodeSpeak, a system explicitly designed for the era of AI-generated software. As developers increasingly rely on vibe coding, chatting with models like Claude to rapidly generate prototypes, they frequently produce unmaintainable, undocumented code bases. CodeSpeak acts as a new kind of compiler to solve this crisis. It extracts human intent from ephemeral chat sessions and translates it into durable, plain English specifications, while the LLM generates and maintains the underlying implementation. Andrei, welcome to the show.
Hi, and thank you very much for this great introduction. I'm very glad to be here.
So what really caught my eye in studying up a little bit on CodeSpeak, and I'll give you a chance to kind of introduce the company the way you want to introduce it and talk about the core ideas, because I think what I'm maybe most obsessed with at the moment is kind of a newer product surface for you. But I have this experience all the time where I'm like, okay, I'm up to 20 terminal tabs open, and I'm 10 messages deep on average in each. And I kind of can't remember what we actually implemented or which ones, I closed my laptop on midway, or, any number of other things that sort of happened that I just lost track of my original intent. So this idea that human intent is all that matters, and the call to action, try intent recovery, is, I think, a really compelling one, even for, a solo kind of explorer like myself. I'm not even trying to ship enterprise software. So tell us, what you think is kind of most important, but that I really am super excited to hear about this notion of intent recovery.
Yeah, so just a little bit of context. So the sort of foundational idea behind CodeSpeak from the beginning was that vibe coding is not the destination, it's a step on the journey. And there will be future steps. And we want to build one of those future steps. And when we started, the term agentic engineering was not really popular yet. But the further we go, the more we can see that CodeSpeak is at the heart of the idea of agentic engineering. Actually, when we were starting, I wrote down this formula that CodeSpeak equals software engineering minus writing code. So we want to keep all the engineering aspects of it, but we of course see that humans shouldn't be writing code manually anymore. So this idea with intent recovery is pretty fundamental, because right now, everybody who prompts agents to get working code, they're doing work that is being like partly accepted and translated into the code, but the rest of it is being discarded. And there is this kind of an unfair situation where you're talking to your agent in English, or like in a natural language anyway, right? And then you get code and you check this code into a repo. And if you're working in a team, other people check your code out, but not the human language, the code, right? So you're talking to a machine in a human language, but talking to your colleagues on the team in machine language. That makes not very much sense. So it's very obvious that there has to be a next level where we all talk in like reasonably high level language, which is close to human language at least. And here, like the simple observation behind what we're doing right now at CodeSpeak is that you already wrote these words down. You may have been speaking into a microphone, doesn't matter. The words happened, and those words were enough to create the code. Like this input determined the code that you got. And like it might have been a back and forth, and you did some testing and so on and so forth, but all that input is what determined the code, right? So that input is enough to describe this code. And most of the time, it's many, many times smaller than the output. So even like replacing the code with that input would be really nice. Excuse me. But the thing is, when you're working with an agent, you have, you change your mind. Basically, you are sort of extracting your intent or realizing your intent as you go. So it doesn't really make much sense to just read all your messages from top to bottom. You need to sort of compress them. If you change your mind, you need the most up-to-date version. And this is what we do. Like we look at this conversation, and it's a little more complicated than just looking at your messages, but to simplify, let's say we look at your messages. And we create a specification based on that. Basically, we extract requirements from what you were communicating. We look at what you requested, what you flagged as errors, which is kind of the flip side of a requirement. And we just put together a list of things you care about that determine the actual output. And then if another person or you later will be looking at this code and will have the set of requirements next to it, that gives you a very concise representation of what the code actually does. And you can imagine that this can be happening like with multiple people doing different things in their own branches. And then, if you merge your thing or like submit a pull request or something, you can look at those requirements instead of code, because the code wasn't written by you anyway. Like what actually comes from a human is the requirements. And, this is how we can kind of elevate what we do to that level. And this is what we call intent recovery. So we take this kind of messy session when you change your mind a lot and do a lot of back and forth, and we sort of compress it and distill the requirements from it. And this is your intent. Like this is the essence of what you are doing. And basically, the next step would be, if you already have requirements for existing code and you want to change the code, the easiest way to do that would be to change the requirements instead of just prompting, prompting all the context around what there is already and what you want to change about that. Just take what there is as a set of requirements, make the changes, and say implement. And that's the overall idea of what we're working on right now.
The observation that you're speaking to your computer in human language, it's translating it to code, and then your human teammates are primarily just then getting that code without access to the conversation that led to it, I think is a, obvious in retrospect, as many of the best observations are, but it's an arresting one, because it is a very strange place that we've kind of vibed ourselves into in that regard. Can you, you were here for the last section of our conversation with Eno previously, and I kind of wonder what your take is on some of the same questions that we asked him around convergence, divergence. I didn't catch any fundraising news from CodeSpeak, so kind of wondering how you are thinking about your place in the ecosystem. Is this something that you kind of imagine maturing into another do-it-all platform, that kind of ultimately like automates a lot of the work and puts people in kind of this sort of managerial role as he described? Or do you have a different vision for the end state, or maybe a more kind of long-term durable niche that you see yourselves occupying while everybody else competes to kind of be the full end-to-end software factory?
Yeah, I guess there are different bets people make in this space, right? So some people make a very safe bet that works for very few people. Like if you can make very good LLMs, go and make very good LLMs. They will be in demand, but very few people can, right? So some people are trying to do this like end-to-end thing, which I think has merit. I also think there is like a lot of uncertainty to that, because we don't really know what will work, and like we don't have many constraints for that. And we know that right now we are very far from full autonomy in agents. Like they can't really complete serious things on their own, no matter what people claim. Like, I've talked to some people who make public claims in private, and it's all there's a lot of nuance to those claims. And this is not to say that agents are not useful. They're useful. I'm not writing code by hand. But it doesn't mean they can like do everything autonomously. So it's a big challenge. And what I sort of am wary of there is that there is not enough constraining reality to figure out what the end game will be. In what we do, I see a lot more constraining reality, because what I'm trying to make CodeSpeak into is a tool that helps humans in the world of coding machines. And there, my vision is actually pretty straightforward. So I don't know what kind of models we get in 5 years. Nobody knows. They may be like considerably smarter. They can be very smart. They can be about as smart as they're today. I don't know. One thing I know is what kind of humans we get in 5 years. It will be the same kind of humans. We'll be as smart or as dumb as we are today. So I think the bet to be helping humans is a much safer one. So what I'm trying to do is basically help humans navigate the complexity of the systems we build, assuming that machines don't take over. So it's not the machines who make all the decisions. It's a human job to make the decisions. It's humans own the intent. And if you're building a complex system, you're not getting away with a short prompt. It's going to be a lot of information you need to communicate to describe the system you're building. And you will not be a single person there. You will be a team. And we know from years and years of software engineering that organizing a complex description of a system is a challenging task. And this is what software engineering is about. If you think back to the early days of computing, people were like writing machine codes manually and assembly and whatnot. And that was a hard part about building software. But then, we got C, and then later we got Java, and we got Kotlin, and the level of abstraction in programming languages was raising quite a lot. But some things just stuck around for the whole time. And those things were dry, KISS, solid. The basics of software engineering were always there. Because it's not about the language. It's about what kind of being you are. You're a human being. You need these things to navigate complexity. And I believe that we will need the same things to navigate complexity in the future. We will be able to manage a lot more complexity. So overall, perhaps it will be even more challenging, but the fundamentals will be the same. And this is why I believe in like agentic engineering as an engineering discipline. And this is why we're building something that, first of all, elevates the level of abstraction. Like, yeah, we are replacing programming languages with human language, hopefully. But then the next step there will be to introduce all the same tools we had in software engineering or in any other kind of engineering we've ever had. Like, having modules, having abstractions, being able to sort of separate concerns in your system, being able to come up with new vocabulary that makes things understandable to humans, and so on and so forth. Machines will not do it for you, because it's not their role. Creating this language is equally important for humans to actually using them. So yeah, this is inherently a human job, I think. And what we're paid for as engineers is organizing complexity. And I hope this is the job we keep, as opposed to typing in machine commands.
So concretely, as I understand it, CodeSpeak has an intent extraction pipeline. You basically start off with the human command, and then you extract intent from there, and you structure it into specifications, which then feed in. And you also very carefully prune specifications which don't trace back to the human intent, as I understand it.
Yes.
So how is it sometimes the human themselves misspecify? I mean, this happens all the time with me. I misspecify all the time, and then I have to take a look at the prototype before I'm like, oh no, that's not what I wanted, right? How do you separate this kind of misspecification on the part of the human from misspecification at the LLM level?
I guess there are two kinds of misspecification.
Yeah.
So one is sort of self-contradictory, or when you request things that cannot be done, like you want to do something, with WS EC2 that WS EC2 does not support, or literally you're contradicting yourself, suggesting requirements that are not consistent, and that's also tricky. But I think what you're asking about is more like when you make an honest mistake and you don't really know what you want to get, and you get something that you didn't want. In my experience, the next step after that is that you look at the prototype, you say, this is not what I wanted, I want to change it this way. And this is where our sort of historic approach to requirements helps, because we treat every message as a delta in your requirements. So when we look at the next message, we always take it in the context of all the previous conversation, and we are trying to extract what requirements are kept around, what requirements are changed, what requirements are dropped. And if you say, oh, this is not what I wanted, let's change it to something else, this is where we just create a diff in your requirements and say, okay, from this point on, these are the requirements that you actually care about.
I can just see that helping, because on every vibe-coded project, as you try to push it into production, you start seeing all of these issues that you come across, and you're like, hey, I didn't mean that. How come?
Yeah.
And I told you kind of 10 commits ago.
Right. So, and this is another aspect in this. It's a very well-known problem that agents often will break working code while building something new, right? So because they've just forgot, or it's in a different session, this session never knew that there was this feature or this requirement. And I can tell it to carefully make everything work on my website on mobile, and then I turn to do another feature, and that feature breaks all the mobile assumptions because I didn't say mobile in the initial prompt. So we can prevent that. Basically, we can just keep all the actual requirements around, and we tie requirements to Git history. So if you're standing on top of the main branch, that all the requirements that went into the main branch will be actual at that point, and they will be in context for whatever new session or existing session runs on top of that branch. I find this very helpful. And there's another thing we're working on right now that kind of surfaces the deltas in requirements every time you submit a new prompt. This is in the works. We are actually reworking the internals of CodeSpeak quite a lot. So the version that's accessible right now on the website is kind of previous generation. We're doing a very interesting rework specifically about Git history and matching things and making things a lot faster. So yeah, I find it very helpful. And it also helps with other things, like onboarding a new person. Like when I take over someone's existing code that they vibe coded, I can't really browse the code anymore because the code is not browsable. I can talk to Claude, of course, but it's much better to know exactly what my colleague meant when they built that. Mm-hmm. And looking at requirements is incredibly helpful.
So how does this actually get integrated into workflows? Are you guys using Claude Code, and then this is sort of a hook that gets tied in there? Or I'm sure you could do it multiple ways, but how are you doing it such that I might learn from your example?
So the previous version is sort of a standalone tool. It just generates an MD file with all the requirements for you, and you can use that, like just put it next to your Claude MD or something. And the next version, we will make it like more seamless so that it hooks into Claude Code, and A, it adds requirements on the fly, and B, it updates its understanding of requirements a lot more seamlessly, like without you really intervening. And so that's basically the difference, because it's like you can reconstruct retrospectively, like look at the Git history and the session history very carefully and match everything together. It like 99% matches, but it's much easier to just be in constant dialogue with you and keep track of all the requirements. And it's also more helpful because the requirements are surfaced at every prompt, and Claude is aware of it.
Do you think this has application beyond software? I'm struck by like legislation. Sounds like the sort of thing that might really benefit from a good intent history log.
Yeah, so it's my pet peeve that we should have been doing law in code for a pretty long time by now. And I think we'll get to a point where we can turn legal documents to something very close to code. And the important thing is that any like contract, any agreement should be executable. You should be able to run a test. Like in these conditions, like in these circumstances, what does this contract entail? And it's tricky to make this work. But if CodeSpeak is very successful, I think we can extend what we're doing to that domain as well. Yeah, and in terms of generally form factors, like what I said about integrating into existing agents, Claude Codex or whatever, it's one possible form factor. I think there is interesting potential in integrating into IDEs, because a good thing about requirements is that they're sort of always around and they're structured. You can surface them in different ways. And it's like when you have an agent session, it's sort of linear context, historic context. But when you are in the context of code, you're in a structured context. You have different components and different level of abstraction. And it's really potentially very helpful to surface requirements in relation to the code you're looking at. Like you may not even care about what the code says. It just gives you the context and the level of abstraction you want to surface requirements for. So, for a sizable project, it can be like thousands and thousands of requirements. You don't want to read them all. And of course, Claude doesn't want to read them all either, but we know how to figure that out. But for a human, it's really helpful to surface requirements in relation to the given code context. Or, we have in the works a plugin for a web framework that lets you just click around in your web app and surface requirements that are relating to that specific component on the screen. But it's very limited to graphic user interfaces. But so whenever you can sort of scope your requirements through some natural context a person is already in, it's very helpful because you don't have to surface like thousands and thousands of requirements. So IDEs, potentially like developer tools for web frameworks, Chrome plugin or whatever, and all other natural contexts a developer will be in.
What have you noticed about the difference in model character? You mentioned, Claude doesn't want to read that. And this kind of calls to mind for me various compare and contrast exercises where people sometimes say Claude's a little more human-like in some ways, maybe gets, the human condition a little bit better. Codex is more maybe diligent, maybe a little tighter on the instruction following, but maybe doesn't have as much instinct to recognize when what you said isn't maybe necessarily exactly what you meant. So what would you say in your particular angle on trying to get value from models? What have you noticed that might be kind of unique takeaways on models, and are you using them in complementary ways, or are you currently finding like one is kind of just the best for what you need?
I'm trying to evaluate more different models, but it's extra work, so I'm kind of a little behind on that personally. Like other people in the team are looking into different agents and different models. One helpful pattern is to have one agent as an MCP tool for another. Like, if your primary agent is Claude, you can use Codex as an MCP tool that can review Claude's work. It's not like a hard proven fact that it works better than just using another instance of Claude for the same thing. But arguably they have like pretty distinct training sets, so they can have different perspectives. I personally don't care very much about the style of responses. I always try to get responses like as robotic as possible, like as concise as possible, and so on and so forth. So not super sensitive to that, like at least to the default styles. I have some like style guidelines that I just paste into every agent I work with. Yeah, there are also some very important characteristics in terms of latency, for example, like for some things. And actually, like in our case, latency is a very important problem because we want to make a lot of small requests. And like if you go to Opus with every one of them, it's going to take ages. And this is why the old version of CodeSpeak is kind of slow. And we're actually looking into combining different models. Sometimes you can go to Gemini. That's Gemini Flash it's considerably faster, but it's like not as versatile in some respects. Or you can try to use a smaller Claude model or whatnot. So we're looking into these things a little bit. We should do more of that, but I think that would be our biggest concern right now. And right now we are sort of in a research phase, so we don't care about cost all that much. But as soon as we get more and more users, we'll be concerned with the cost as well.
So do you think you will end up using some of the Chinese open source models? Is that on the horizon?
It can be a thing, yeah. So Chinese or non-Chinese open source models. It's the interesting thing about the modern software engineering is that more and more of it is not software engineering anymore. More and more of it is machine learning. And in the machine learning space, data is more important than code. Very often, data is more important than algorithms. So, if you have a very good data set that kind of captures what you want to do, then you can take an open source model and fine tune it. The big question is where you get the good data set. And that's really tricky, and we've been doing some work there, and we'll keep doing a lot more work there. But yeah, I think at some point, possibly pretty soon, we'll be looking more and more into open source models and fine-tuning them, and also like fine-tuning in a very broad sense. It doesn't have to be fine-tuning specifically. It can be RL or something like that. Post-training them in some way. And that can be a big cost saver for our users. It can be also a boost in latency. So, there is potential there. And a lot of modern open source models are pretty good. They're still too big to run locally, but we can host them ourselves.
Cool, fantastic. I would say we can put you safely in the category of diverging from the end-to-end software factory paradigm companies, including Factory itself. So that's good. And I look forward to the day. First of all, we'll definitely be trying this out in my stack and see what kind of intent recovery we can glean off the cutting room floor of our own work. But also really looking forward to the day when you achieve the big vision of extending this to other areas beyond code, and we can live in a much more coherent, predictable, high intent, high signal legal environment as well. I think there's
that could take a bit of time, but I'm really looking forward to that world as well. Yeah.
I just want to ask maybe one kind of question. As a really kind of historical figure in programming, how do you feel about the way that software engineering is changing now with these models? I mean, looking back, I feel like a lot of software developers have this nostalgia almost for an art that is being lost. So how does that, emotionally, like how do you feel about this entire process of handing over the code to the model, so to speak?
I think I'm very skeptical about this actually happening in the sense that a lot of people are lamenting. Maybe it's my internal bias, which is, helps me keep optimistic or something like that. I also remember the UML days. I'm old enough to do that. And I even caught the tail end of working on UML related stuff. And that was a complete it didn't really work. This one works much better, and it actually brings value. But I also know how much people can sort of project and fantasize about a bright future that blows things out of proportion. And what I see in reality right now is that software engineers struggle to even improve their own productivity, let alone delegate everything. And it will improve. People will figure out how to use these tools. The tools will get better. We will definitely delegate a lot of low-level engineering tasks to those tools. But so far, I keep an optimistic outlook on humans remaining engineers. And as an engineer, I never cared about writing assembly by hand. Some people enjoy that, and they remain the experts, and they have good, well-paying jobs. But there are few of those. And because there are a few of such people, well, not because, but incidentally, there are a few such people. And I'm not one of them. So I'm personally, I don't care about doing low-level work. I want to do high-level work. And I think these things will enable us in doing high-level engineering. It's very hard. It's always been very hard. And I'm looking forward to the world where I can really focus on the hard stuff.
We're definitely looking forward to that world too. Andre, thank you so much for your time. We look forward to using CodeSpeak and trying it out.
Yeah, thanks a lot for having me. It was great to chat.
We'll report back. Appreciate it.
Thank you.
Bye for now. All right, I've got a wrap. I mentioned Dean Ball would be mentioned again, and it has broken news on the timeline that he is joining OpenAI. So there's a big development for him, and there's going to be a whole new team that he'll be leading that will be, advising OpenAI leadership on how to hopefully steer AI policy in the right direction. And I got to go talk to him now. We're going to hopefully have a episode of the Cognitive Revolution coming with his kind of full backstory, reasoning, and everything that has gone into this decision. So got to be quick on the exit today, but look for that coming soon. And this has been another really good week. We're off tomorrow, but we'll be back next week. So folks can also watch out for a weekend highlights episode coming soon.
All right. Bye-bye.
Thanks, Prakash. Bye for now. All right. Calling him back actually right now.
Yeah, crazy. Things move fast.
Yeah, no doubt.